Und ja, dann kommen wir auch direkt zum nächsten Vortrag. Und der hat den Titel The Tool for the Visualization of Variant Structures in Virtual Reality. Das Ganze ist ein Short Paper, wird als Video vorgestellt und wird vorgetragen von Herrn Küntzer. Herr Küntzer ist an der Hochschule Trier und hat die Arbeit zusammen mit dem Herrn Rock gemacht und wir können das Video jetzt starten.
Hello, my name is Lukas Küntzer and I am a research and teaching assistant at Trier University of Applied Sciences. My co-author and I would like to thank the organizers for the opportunity to present our paper during this workshop. As the title suggests, this presentation is about product variants, so we start with that. In today's economy, product customization is the trade that turns a profit. Product developers and manufacturers aim to fulfill the customer's individual needs and to engage with them on an individual level for a maximum of customer retention and brand recognition. The automotive industry was and remains a pioneer of the hardware market in that regard. The highly customizable cars result in some components coming in thousands of different variants. Popular examples include 3,000 different BMW X3 door designs and 90,000 headliner variants of the same vehicle. Overall, this results in a staggering product complexity for development, manufacturing, and maintenance. This overwhelming variance needs to be conquered, and there is a pushback towards modularity and standardization. The automotive industry, for example, has long introduced product lines and common drivetrain platforms. Still, the product variance needs to be modeled throughout the entire life cycle. But how? Of course, there's the age-old battle between different visual media. Commonly, system designers and business managers are more used to tables and large variant sheets. Those are great for looking at minuscule details and constraints, but they fall short in providing an overview of a bigger picture. This is where diagrams, graphs, and in our case, feature models in tree layout come in handy, as seen here at the example of a truck product line. Trucks can be distinguished by weight, amount of axles, cabin size, engine power, and what task it's suited for. Some of the traits in a given truck configuration would exclude each other, while others depend on each other. As you can imagine, a screen gets filled up quickly by the likes of a 2D feature model that results in 3,000 different car doors. It's just not very space efficient. Feature cone trees have been shown to circumvent this problem, and they make much better use of the available space, while retaining a clear-cut hierarchy. On the right side, you can see them in a vertical and in a horizontal layout. Now, if we wanted to make the best use of our available screen space, we could always lay out the tree in hyperbolic space, which would be a theoretical solution to our foremost concern. However, while this might be quite beneficial for visualizing cross-tree constraints, it is already quite a leap for an engineer or a decision maker to go from tables to trees to cone trees in virtual reality. Feature cone trees are a nice compromise between what's theoretically possible and what's practically feasible and familiar to the user. With our project, we pursue the following research goals. We want to qualify and quantify the benefits that 3D VR really has on development teams and variant management. Specifically, we're targeting small to medium-sized development teams with that. We're looking for applications and methodologies that can be integrated in established processes in product development. We don't think that VR in its current state will be a great tool to constructively design in. We, however, think that it can be a very powerful tool for communication and decision making. Something we personally haven't much experimented with are the possibilities of multimodal interactions, something which we aim to remedy. Just like with different forms of interaction, we want to determine the impact the access to different styling themes has on user acceptance within various fields. After all, to work with it productively, we think users have to feel familiar. Fortunately, we are not starting at zero. Glencoe, as seen in the screenshot below, is already an accomplished tool for visualizing even large feature models. More than that, it comes with a whole suite of analytical tools and satisfiability solvers. My co-author and others have been developing it since around 2012. What we are developing in the scope of this project is a VR extension of this desktop tool. Our design in VR considers that we want to make the switch back and forth as easy as possible. Down the line, the VR tool shall be able to communicate with the Glencoe server directly and pull from a library of 3D engineering models. Especially the latter is a challenge in itself, if we want the application to stay engaging and usable. We are trying to design an engaging, interactive environment which supports exploration and creativity in multi-user sessions. Variant structures can come in all shapes and sizes. Our feature models often come with a high node degree at the top levels, but a low height overall. Product structures in engineering, on the other hand, are often very high trees, but you still want to access deep nodes there. As such, we aim to offer both a vertical tree layout that builds itself around the user and a horizontal layout that can spread into infinity. Users are then able to interact almost playfully with the nodes, links, and 3D models. They can manipulate the feature model, build a configuration, and explore the product's design spaces. Touch menus, driven by finger tracking, allow access to the multitude of settings and workbenches that allow individual customization if so desired. The other challenge, next to the scalability to accommodate to the incoming feature model, is the issue of visual clarity. It does become cluttered. It's way better in VR than in the screenshots, but there is still a lot of information in front of your eyes. That's desirable though. You want to access lots of information. At best though, only the information that you actually need in that instance. There are many ways to work towards that. Some obvious, some less so, and we've taken a look at the works of a lot of different researchers and the feature model and graph visualization field in our paper. Examples to transport information visually and guide the user's focus include, of course, color, size, motion, and shape. But there's also filtering, collapsing, and expanding of subtrees. Transparency or lack of display for text, icons, and constraints are also a possibility. In the end, you always have to weigh between reducing visual clutter and information access. Our major contribution in this context are the visualization of additional subtree instances and the display of cross-instances, cross-tree constraints. This can be likened to a multi-window view with constraints crossing window borders. This is bewildering in a 2D or a 2D projection environment, with the lines easily covering each other up. In VR, the differences in position are of course way easier to discern, and one can just tilt the head a bit if needed. To summarize, the biggest challenges are the large-scale feature models that need to be displayed and the visual clarity that needs to be achieved without burdening the user too much. The tool needs to be able to be integrated into already existing processes, and users need to be able to work productively with it. The tool as proposed by us will not be able to replace desktop work and large tables when it comes to the fine details and constraints, at least not in the current state of VR. However, We believe we're building an engaging tool that helps users to understand a system in the big picture and from the ground up. Such an application offers a superb opportunity for remote communication between teams in design, validation, and decision-making processes. In outward communication, it's great for marketing and sales with a customer. And this marks the conclusion of our presentation. Now I'm happy to talk to you, and I'm looking forward to answering your questions. After the workshop, you can also reach us via email. Thank you.
Herr Küntzer, vielen Dank für Ihren interessanten Vortrag und Ihre interessante Arbeit. Ja, dazu erstmal vielen Dank und
Gerne.
die Zuschauer können gerne auch ein wenig Applaus geben. Und ich denke, wir kommen jetzt zur Fragesession. Ich gucke gerade mal bei Slido, es sind noch keine Fragen eingegangen. Gerne Fragen dort eintippen. In der Zwischenzeit hätte ich eine Frage. Sie haben in dem Paper ja geschrieben, dass Sie eine User Study geplant haben. Das hat es nicht mehr ins Paper geschafft. Können Sie das noch mal ein bisschen näher ausführen? Vielleicht hat die ja schon stattgefunden oder wie ist die Planung für die Zukunft in dem Bereich?
Genau, also wir hatten im Vorfeld schon ja in einem interdisziplinären Projekt bei uns, wo Informatiker mit Maschinenbauer, Fahrzeugtechnikern zusammenarbeiten, hatten wir schon mal eine kleine Startstudie gemacht zur Annahme von VR-Tools in deren in deren Projekten zur Produktentwicklung. Und natürlich war geplant, das Ganze dann auch nochmal durchzuführen, sobald der Prototyp halt hier eben steht, und das tut er nun. Nur haben wir halt eben die großen Hindernisse bei richtigen VR, also bei VR-Studien dann mit Headset und so in der aktuellen Situation. Es ist aber nach wie vor geplant, sobald es denn auch bei uns vor Ort nochmal besser möglich ist, mit 20, 30 Maschinenbaustudenten in ihren Projektphasen eben genau das dann durchzuführen, gegebenenfalls auch mit einem Partner aus der Industrie. Und da schauen wir dann auch auf ein Projektteam von 20 bis 30 Konstrukteuren, die das dann eben dann auch mal ausprobieren können, schauen, wie könnte das eben in den Produktentwicklungsprozess integriert werden und wo muss es denn eben noch verbessert werden, um auch eben produktiv zu sein.
Mhm. Ja, jetzt kommt sogar eine Frage über Slido noch rein, und zwar von einer Frau oder einem Herrn Tümmler. Und zwar, die aktuellen Datenstrukturen sind hierarchisch angelegt, und würden sich Ihre Methoden ändern, wenn graph-basierte Datenstrukturen verwendet werden könnten oder man darauf wechseln würde?
Ja, also das große Problem ist ja, man kann auf theoretischer Basis da über viele Sachen reden, aber dieser Umschwung, der müsste dann natürlich auch stattfinden in der Industrie, also tatsächlich beim Anwender. Und da ist es halt nun mal jetzt schon sowieso noch so, dass da die meisten eben auch schon ausgebildet werden und dann während der Arbeit hauptsächlich mal mit Tabellen arbeiten. Und da ist es ja schon für die ein großer Umstieg auf auf die Bäume, auf diese Graphen, also auf diese semiformale Darstellungsform.
Mhm. Okay, dann haben wir keine weiteren Fragen. Und dann ist nochmal Zeit für einen weiteren Applaus. Vielen Dank für den Vortrag, für die Beantwortung der Fragen.